Hey, it's Dan and it's February 6th and I'm here in my office working on building an open source servo, and I'd like to show you the problem that I have. Maybe you've got some ideas about how to make it better. So join me now. So I have an UNO here with a stepper motor that's tied through a coupler to a sensor. You can see the chip in here, and there's in here there's a magnet that's held in place with a bearing and these 3D printed parts. The magnet has to be in just the right spot for the sensor to work correctly. Over here I have the chip. This is a A4988 chip that drives the stepper motor, and that all comes from a 12-volt supply. And this is a frame that I laser cut that's holding these pieces together, and eventually I'm going to glue this down along with the breadboard so I can put this in a box and take it to the hack space. The servo detects that human interference is involved, and then it goes limp for a brief period, and it goes limp until the human interference leaves. And when there's no human interference, it's always driving back to the target position, so you can push it out of the way, and then when you're gone it will resume normal working conditions. It should also understand, you see, I should be able to push it while it's doing a job, and it understands that the human wants it to go somewhere else. That way it's safe to operate. But I don't know if you can really see it, but that's a smooth motion, and it fights me a bit when I turn the other way. And once it reaches its, now if I push it this way, there was a little tunk at the start when it's still initially fighting because it's not sure there's human interference. I understand that. But the other way, there's a lot more interference. I don't know why there's more one direction than the other. Alright, so on the screen here, we can see, hello IRC, we can see these numbers, and the first column is time, and then indicators about what the servo is deciding to do, and then the distance the servo has to move, and finally a flag of the number of steps the stepper motor has moved this tick. Every tick is as fast as possible. The D means that the stepper motor has been disabled temporarily. The M means that the magnet sensor has detected rotation turning. And the S means that the stepper motor has stepped in some direction. So there's a difference between the stepper motor stepping or trying to turn the shaft and the sensor detecting a movement. It could be slop, it could be human interference, and so in the case, what we're trying to do is find the difference between when we want to move and when we can actually move, and if for any reason we can't move, then we assume that there's human interference and we should hold off. And later, one of the things I hope to do is to expand this so that I can have a button that I push that sets it into record mode, and then I push it around, and then I can play that back. I am putting a link to the code on GitHub in the description of this video. If you could like, share, and subscribe, that way it'll reach as many people as possible, and hopefully one of the people watching this video is going to have some great ideas, which they will put in the comments, and together we will achieve success. So, thank you very much for watching, and we'll see you again soon.